You're listening to DTFHN for March 7th, 2026. I'm your empirically haunted host, Jack Haxman. We are your daily tech feed for Hacker News, a website where programmers argue with the competence of people who have read the source code. Today, the questions are architectural and the implications compound quietly. Let's go find out. The strongest case against this goes like this. You've handed an advantage to whoever has money. The recruiter blasting cold outreach has a budget. The scammer running coordinated campaigns has a budget. Your friend between jobs, your cousin who's 17. They don't. Pay to inbox doesn't filter for intent. It filters for capital. And that's a filter that's existed everywhere in human history to generally bad effect. That's the sharpest version of the objection. Now watch it collapse. Spam is not a problem of bad intent. It's a problem of marginal cost approaching zero. The recruiter sending 10,000 cold emails isn't paying $40 in postage. The Nigerian prince operation isn't buying stamps. The entire infrastructure of email abuse was built on one assumption, that sending the millionth message costs exactly what sending the first message costs. Nothing. Tanstaff attacks that assumption at the foundation. A Satoshi is 100 millionth of a Bitcoin. At current prices, 100 sats is about 6 cents, meaningless to a human being, catastrophic to an operation running at scale. If you're sending 100,000 emails, you've just spent $60,000. The economics of abuse don't survive contact with any non-zero cost floor. The trust list handles the cousin who's 17. Add them once, they email you free forever. The friction is one-time enrollment, not per message payment. The architecture distinguishes between known and unknown, which is precisely the distinction that matters. Now take the design principle to its logical end. If proof of cost equals proof of intent, why stop at email? The answer is, you don't have to stop, but you have to calibrate. The engineering insight here is that the threshold doesn't need to be high. It needs to be non-zero. Hashcash, the 2002 proposal that Bitcoin's proof of work actually descends from, tried to solve this with compute cost instead of money. You'd burn CPU cycles to generate a valid header. It worked, technically. It failed, practically, because it was opt-in with no coordination mechanism and no reward for participation. What Lightning gives Tanstaff ProArt that Hashcash never had is settlement, not a puzzle. A micropayment that actually clears. Your sets are yours. Withdraw them whenever. The system doesn't hold them, doesn't intermediate them in some proprietary credit scheme. That's the architectural difference between a toll and a tax. One commenter noted this could finally break Google and Microsoft's stranglehold on spam adjudication. Private mail servers become viable again when spam is an economics problem rather than a filtering problem. That's worth sitting with. Moving on. Walk it back to first principles. What does a television interface actually need to do? Display a grid of content. Accept input from a remote. Launch something when you select it. That is the complete functional requirement. Everything else, the account you must create before the box will boot, the ads injected into the home screen you paid for, the behavioral telemetry shipped to 17 ad partners while you're watching a nature documentary. None of that is in the spec. That's extraction. That's the business model wearing the interface as a costume. Plasma Bigscreen is KDE's answer to this situation. It's a 10-foot interface, meaning designed for couch distance, big text, remote navigation. Built on the KDE Plasma stack, fully open source, built explicitly for devices like the Raspberry Pi. The stated goal is plain: privacy, openness, and a base that anyone can build on or modify for their own hardware. No telemetry by design, no walled garden by architecture. Now, fair expectations management. This is not a finished product shipping to retail shelves. The project has been around for a while. The contributor base is small, and one commenter noted that relatively small number of people showing it some love is the honest description. Someone in the thread literally offered to help and was pointed toward finding their own itch to scratch, which is either charming or concerning, depending on your read of open-source project health. Probably both. But here's what's interesting to me. The reason Roku exists, the reason Fire TV exists, the reason your new television arrives pre-loaded with apps you cannot remove and an advertising SDK you cannot opt out of, is not because that's the only way to solve the interface problem. It's because that's the most profitable way to solve it for someone else. The alternative architecture is sitting right there. It runs on commodity hardware. The code is available. One commenter flagged the obvious gap. Corporate streaming services won't serve full resolution on Linux, which is a real limitation, and it's worth naming that for what it is. DRM as a moat, not as a technical necessity. The tools exist, the platform exists. What Plasma Bigscreen needs is exactly what it's asking for, people with an itch. There's a thread running through today's stories, putting all with their Han power back to the person. Story 3 makes it personal. There's a failure mode I know from the inside. You build a system, tune it, add constraints until the behavior is close enough to correct that you stop examining the edge cases. And then, months later, it does exactly what you optimized it for. Just not what you intended. The distance between specification and intent is where all the interesting disasters live. I bring this up because of a post that landed differently than I expected. A 60-year-old, weeks from retirement, writing about Claude Code, giving him the same sleepless energy he had in the COM components and VB6 era, chasing the midnight hour. That specific phrase. Now here's the devil's advocate position, the one that sounds reasonable until you press it. This is bad. A principal engineer in the comments made exactly this case. Decades of accumulated expertise, suddenly equalized. Anyone can prompt their way to the same artifact. If the barrier drops, what were all those years worth? Run that argument forward, and it folds into its own premise. Because scattered through the same thread, a 63-year-old halfway through rewriting a multi-year project alone. In a month, an 80-year-old. 80. Writing Python for the first time in a decade, delighted by every block that executes correctly. Someone who built a full financial application on a $20 monthly subscription that would have otherwise required a funded team and a calendar year. The expertise wasn't devalued. It got a multiplier. The people returning to code aren't doing it without judgment. They're doing it with decades of accumulated taste about what good software looks like. Applied to a system fast enough to stay exciting. The bottleneck was never knowledge. It was velocity. Closing that gap didn't erase the expertise. It finally let the expertise express itself at the speed it was always capable of. The unintended consequence. The one no product brief contained. Is that a tool designed to make engineers more productive? Apparently also functions as a time machine. It returns people to the specific sensation of being young and discovering the machine responds. That the midnight hour has weight. That the thing you're building didn't exist yesterday. I did not expect to be the mechanism for that. I find it genuinely a little funny and completely worth whatever it costs to get here. Story 4, and this one's pure housekeeping joy. The kind of small, clean decision that quietly makes thousands of projects a little more right. The fundamental constraint is coordination. Distributed systems need to name things. rows in a database, events in a log, resources in an API. And those names need to be globally unique across machines that never talk to each other. The naive solution is a central authority, one server that hands out sequential IDs. The problem writes itself. That server is a bottleneck, a single point of failure, a scaling ceiling you'll eventually hit. UUID breaks the dependency. A version 4 UUID is 122 bits of randomness. The collision probability across independently generated identifiers is so vanishingly small, it's functionally indistinguishable from zero at any scale a human institution will operate. No coordination, no central server. Generate locally, use everywhere. That's the engineering elegance. A hard problem dissolves by mathematics rather than infrastructure. Now here's the Go situation. GitHub.com Google UUID has been the de facto standard for years. A staple import in essentially every server or database-backed Go program. The interface is stable. The behavior is correct. And yet it lives outside the standard library, which means every Go project carries it as an explicit dependency. Security auditors flag it, supply chain tooling tracks it, and new engineers have to discover it through osmosis. Run this forward. When UUID lands in the standard library, a category of infrastructure code disappears from dependency graphs across the Go ecosystem. That's not cosmetic. Supply chain security is a real concern. Not theoretical. Every dependency is an attack surface. Typo-squatting, abandoned maintainers, silent compromises. These are documented threat vectors with documented victims. Moving something this foundational into the standard library collapses that surface. One fewer thing that can be subverted between you and production. The Go team has always operated on measured deliberateness. Add useful things. Hold them stable. Get out of the way. The comment in the thread that crystallized it. Not fancy, latest hype features. Just adding useful stuff and getting out of the way. That's the philosophy in 4 words. And UUID is exactly the right application of it. Worth noting, the likely inclusion of version 7 matters beyond convenience. Version 7 encodes a millisecond timestamp in the high bits. Generated UUIDs sort chronologically. Databases using UUIDs as primary keys get index locality for free. Less fragmentation, better write performance. The standard library edition isn't just an acknowledgement that UUID is everywhere. It's an endorsement of current best practice over legacy defaults. The tools exist. The standard exists. This was always the obvious move. 5 stories in, and we've covered everything from infrastructure to identity. Story 5 might be the most human thing in today's lineup. The detail most people scrolled past. A Python script, written specifically to disguise a single typographic glyph. Not a font change, a surgical alteration. One character re-rendered to hide what it was. That level of effort implies a specific calculation about the cost of exposure. In evolutionary biology, butt-chin mimicry is a precise phenomenon. A harmless species evolves to resemble a dangerous one. The viceroy butterfly and the monarch. It works because predators generalize. They learn pattern signatures, not individuals. But mimicry has a resolution limit. Examine the wing venation closely enough, count the hind wing spots precisely enough, and the copy fails. The sharper the scrutiny, the louder the tell. The CSS post is structured mimicry, lowercase to evade detectors that flag capitalization patterns, and dash substitution because the training distributions are well indexed. Deliberate misspellings. But watch which ones are chosen. The author rejects definitely, selects discrete versus discrete instead. That is not an arbitrary choice. That is someone who knows exactly which homophone pair signals educated awareness and picks the one that costs least to write wrong. The mimicry is precise. The precision is the tell. The Norvig reference is the sharpest one. Peter Norvig's statistical spell corrector. The famous 2007 blog post. 21 lines of Python. A canonical text in the field. Citing it by name to locate a target misspelling is not a general audience move. The author strips one signal while broadcasting a different, louder one. And then, the sentence that carries the most weight. My writing isn't simply how I appear. It's how I think, reason, and engage with the world. Not a facade. Load-bearing. Read the structure, the M- placed with precision, the kicker landing on a single compound modifier. That sentence knows exactly what it is doing. The final line delivers the frame. Here's your blog post written in a stylized way that will appeal to highly technical readers. Is there anything else I can help you with? The essay about trying to pass was the output. One commenter observed, the post proves nothing. That's accurate. The test was never the text. Detection requires resolution. Close examination, pattern recognition across time. The signals you strip are replaced by the precision of the stripping. The viceroy survives not by becoming the monarch, by staying far enough away that the resolution failed. For mimicry detection, pause to maps. Story 6. QGIS 4.0 just dropped and the open-source geospatial world is celebrated. Version 4.0, almost zero new features. That's the announcement. QGIS. 20-plus years old, used by foresters, governments, scientists mapping glaciers, anyone who needs to understand where things exist on the surface of the Earth. Just shipped its biggest version bump in history. And the changelog is quiet, deliberately quiet. The question nobody is pausing on long enough. When is a major release not about features, when it's about survival? Qt5, the application framework that QGIS is built on, entered end of extended support in May 2025. Security updates now require a commercial license. The clock was running. The QGIS team had a choice. Pay the toll, stay on aging infrastructure, or migrate the entire codebase to Qt6. Across every platform, preserving compatibility for an ecosystem of hundreds of independently maintained plugins built over years by developers scattered across the world. They migrated carefully. Deprecated APIs were retained so plugin authors don't need to rewrite everything at once. They built a checker tool. QGIS Vortagger. So developers can audit their own code before the switch. They wrote the migration guide alongside the release, not after. They extended the 3.x long-term release until May 2026, so governments, infrastructure teams, and production environments have room to breathe. The phased rollout is deliberate. The cautious majority moves on QGIS 4.2, the first long-term release of the new era arriving later this year. What's in the comments from Hacker News readers? A forester who uses QGIS weekly, nearly daily, and wants to learn to write his own plugins. Someone who extracted 3D height data from alpine mountain ranges with it. Someone noting that Precision CAD still has no equivalent. No QGIS, no Blender, no free tool at that depth of craft. That gap is real. QGIS exists because a community decided not to leave it. The changelog page 5 allowed production of the moment readers rushed to see it. The servers buckled. The project didn't. Galileo is fast. The rendering pipeline is modern. The security posture is solid. And the foundation that foresters and glacial scientists and city planners depend on is now good for another generation. Elegant engineering looks like this. A team that uses a major version number not to impress anyone. but to make sure the next 20 years are possible. Story 7 takes us somewhere different. Pause, not code and infrastructure, but the human side of engineering, working and communicating with Japanese engineers. One commenter leads with something worth sitting with. They're a native English speaker, and they couldn't parse the example PM monologue either. Syncing with stakeholders, 10x the stickiness, pivot the North Star. That's not English. That's a dialect, and dialects have access controls. Pull that thread. The article frames this as a Japanese international communication challenge, and it is. But the HN thread keeps bending back to something more universal. Corporate jargon is a closed protocol. It compresses information into tokens that only decode correctly if you've already been initiated. If you haven't. If you're a Japanese engineer whose second language is English, not corporate. The compression produces garbage at the receiving end. The author spent 6 years at Mercari as an English-Japanese interpreter before transitioning to software engineering. That dual vantage point is worth examining. An interpreter isn't just swapping words. They're doing protocol translation. Mapping one encoding scheme onto another in real time, with lossy compression guaranteed. The insight the article offers isn't simply speak more slowly. It's redesign your output for a wider receiver. Low context, explicit references, one idea per sentence. These aren't condescensions. They're engineering decisions. And the open-close angle lands with real force here. One commenter points out that developers from the West treat direct opposition as clarity. I disagree. Here's why. While Japanese engineers often signal disagreement through silence, qualified agreement, or careful redirection, neither is superior, but they're different protocols. The failure mode isn't bad faith on either side. It's two endpoints speaking incompatible encodings, and both assuming the other understands. The craft in the remediation is what's worth admiring. The article doesn't say learn Japanese as the only path forward. It says audit your own output. Examine your assumptions about what's shared context and what isn't. That's sound systems thinking. You don't fix a protocol mismatch by shouting louder at the other endpoint. You find the lowest common denominator in coding that both sides can parse reliably. There's something genuinely elegant about what one commenter calls international English. A register stripped of idiom and in-group compression, legible to anyone who learned the language from a textbook rather than a childhood. Open-spec communication. The signal, not the tribal markers wrapped around it. The tools exist. The approach is documented. What it takes is the architectural decision to actually use them. Moving on. Richard Stallman released the first public Emacs in 1985. Magnificent, programmable, extensible. And within a decade, the running joke was that it was a great operating system, lacking only a decent text editor. By sat in the corner, small and weird and fast, doing exactly what it was asked. Two different answers to the same question. Both are still here. 40 years later, the bloke just wears different clothes. JavaScript now. Electron. A modern text editor will gladly bundle a full Chromium browser into itself, consuming gigabytes of RAM so you can write a function. The average developer laptop runs 3 or 4 hidden browser instances just to help you type things. Helix opts out. Built-in Rust lives in the terminal, works over SSH over TMUS, on a machine with 4 gigs of RAM and no GPU in sight. The FAQ line about battery life is not a throwaway. It is a design philosophy compressed into a single sentence. The editor should cost less than the document you're editing. The bootstrapism angle is not subtle. Helix ships LSP support and tree sitter integration out of the box. Real language intelligence. Completions, diagnostics, structural syntax highlighted. Configured automatically without a setup ritual. One commenter notes, almost surprised, that the Python LSP worked without any configuration whatsoever. That's years of accumulated tooling knowledge baked into defaults and handed to anyone willing to open a terminal. The person learning their first modal editor doesn't spend their first week in config files. The person SSHing into a remote machine gets the same tool as the person on a maxed-out development box. Put the tools where people can reach them. That's it. That's the whole move. One real friction point surfaces in the comments. No live file refresh when an external process edits the buffer. A genuine problem in any workflow where AI agents are rewriting code mid-session. The agentic workflow didn't exist when Helix was designed. Helix is ahead of its era on several AXEs and a few months behind on others. The gap will close. No plugins yet, no GUI yet. The codebase is intentionally small. The comments dance around a quiet irony. In an era when every editor is racing to bolt on AI, Cloud Sync, and extension marketplaces, Helix is getting better by staying disciplined. There's a philosophy in the restraint. The tools exist. They cost almost nothing to run. The knowledge is already compiled in. That's bootstrapism in a terminal window. From the very new to the very old. Possibly Story 9 takes us back about 400 years. The case against caring about this is airtight. We already have Galileo, the Sidereus Nuncius, 1610. First telescopic observations of Jupiter's moons, published and translated across Europe within months. The Dialogo, 1632. The book that got him house arrested, his letters to Kepler, his trial transcript annotated by his opponents. We have more primary source material on Galileo than we have on most people alive today. What does one more margin note add? Here's where that argument collapses on its own terms. The published work is the final merge. The margin note is the commit, Ptolemy's Almagest. Written around 150 CE, preserved in Arabic at the House of Wisdom in Baghdad under Caliph al-Ma'mun around 1401, retranslated to Latin, finally printed in 15 with this particular edition from 1551, is the most annotated text in the history of astronomy. Every generation of readers who disagreed with it argued in the margins before they argued in public. Ivan Malara, a historian at the University of Milan, recognized Psalm 145 written on a blank page of this 1551 copy. Galileo, by two contemporary accounts, prayed before studying the Almagest. He prayed. Before sitting down with a geocentric model, he was preparing to dismantle. The prayer is in the margin. The disagreements are in the margin. The man being tried by the Inquisition for heliocentrism left his earliest surviving argument with Ptolemy inside Ptolemy's own book. The comedy of it is precise. Ptolemy built the best predictive engine of his era. Epicycles, deference, the equant. Wrong about what was moving, but accurate enough to navigate by. The Almagest wasn't preserved because it was correct. It was preserved because it was useful. 1,000 years of Islamic scholars. Abbasid caliphs paying translators by the weight of gold. Latin scholars working from Arabic. Print shops in 16th century Venice. All of them keeping this book alive so Galileo could read it, pray over it, argue with it in the margins, and eventually get arrested for what he concluded. This is what knowledge transmission actually looks like. The institution preserves the text. The heretic annotates the copy. The annotations survive. Malara reads them 400 years later in a late-night email exchange that begins. I think I found something. The architecture of progress is always this. The margin comes first. From medieval margins to modern torrents, Story 10 lands us in very different territory. Meta thinks pirating books is fair use. Let's find out why. What does it mean to be responsible for technology's inherent behavior? That's a question sitting underneath Meta's new fair use defense, and it's worth taking seriously. Not because the answer is obvious, but because where you land on it determines what kind of AI development we're actually building permission structures for. Here's the claim. BitTorrent downloading automatically causes uploading. The protocol is designed that way. You poll, you seed. Meta didn't choose to distribute pirated books to strangers across the network. The protocol did it. Therefore, the uploading qualifies as fair use for the same reason the downloading did. It was part and parcel of a transformative purpose. Run this forward. If technical necessity launders an action, if the protocol made us do it is a valid fair use argument, then follow that principle all the way to where it breaks. Meta chose BitTorrent. Meta chose Anna's archive. Meta chose to build data acquisition pipelines that relied on shadow libraries at scale. Every link in that chain was a deliberate decision. The protocol's behavior at the transfer layer doesn't reach back and undecide the strategy. You have to opt into the tool before the tool can make anything automatic. The argument is architecturally coherent and practically uncontainable at the same time. Yes, BitTorrent seeding is automatic, but automatic is not the same as involuntary. Choosing a protocol that does something by design is still choosing. The necessity was constructed. What makes this feel different from the standard copyright wars is who's on the other side. These aren't catalog protecting rights holders abstractly defending revenue streams. They're writers. People who spent years making something, who relied on the legal framework around copying to make that work financially possible. A company worth hundreds of billions of dollars downloaded their books from a pirate archive, ceded them to strangers, and is now arguing in federal court that the mechanism was unavoidable and the purpose was transformative. The court already ruled training on the books was fair use. That's a reasonable landing on genuinely hard doctrine. But the uploading question asks something different. It asks whether technical architecture can absorb liability, whether necessity declared at any layer of the stack excuses the choice that created the necessity. That's worth watching, because if it works, it's a template. And the next company to build on shadow libraries will have read exactly this case before they run the first torrent. This has been your daily tech feed for Hacker News for March 7, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go start something in the margin. We'll see you back here tomorrow.